Hello, this is Zhongye at Computer Engineering major, and now I will demonstrate the solution of homework 10 of ECE6303 question 1. In this question, we need to collect the definition and simple properties of examples of statistics process and explain understanding about this process. First question is Poisson process. And we can get the first order probability masses. The probability xt equals to k equals to e minus lambda t, and then multiply lambda t to k over factorial of k. The mean of the xt is lambda t. The autocorrelation T1, T2 equals to lambda squared T1, T2 plus lambda multiply mean T1, T2. The autocovariance C T1, T2 equals to lambda multiply mean T1, T2. We can find that the mean is lambda t, which is a linear function of t. We can expect that the longer time we wait for the expected number of buses is larger. Now question 2. It's Poisson increment. It is defined as yt equals to xt plus epsilon minus xt over epsilon. Here xt is a Poisson process. So the first order probability yt equals to n over epsilon equals to e to minus lambda epsilon, then multiply lambda epsilon to n over factorial of n. The mean is expectation of yt equals to lambda. The autocorrelation Rt1, T2 equals to first lambda squared, and the condition is the absolute value of T1 minus T2 is larger and equal than epsilon. The second solution is lambda squared plus lambda over epsilon, then minus lambda T1 minus T2 absolute value, then over epsilon squared. Here is T1 minus T2 absolute value is less than epsilon. The autocovariance CT1, T2, it also has two values. First is 0. And we also have the absolute value T1 minus T2. It is larger than epsilon. The second is lambda over epsilon minus lambda T1 minus T2 absolute value over epsilon squared. Here is the absolute value T1 minus T2 is less than epsilon. In autocorrelation, we can find that the T1 minus T2 epsilon is less than epsilon. Is a triangle with area lambda, which is independent of epsilon. When epsilon approaching to 0, the triangle becomes impulse with area lambda. Then the third question is boson impulse. It is defined as Zt equals to the differential of xt to dt. Here xt is the boson process, and we can get the first order probability masses. It has no definition, and the mean expectation of Zt equals to lambda. The autocorrelation RT1 T2 it equals to lambda squared plus lambda delta T1 minus T2. The autocovariance CT1 T2 it equals to lambda delta T1 minus T2. The process Zt minus lambda has zero mean, and RT1 T2 equals to lambda delta T1 T2, and here Zt minus lambda is white noise. Then question 4, it's semi-random telegraph signal. The number n of points in the interval T1, T2 of length T2 minus T1 is a boson random variable. And we can define this xt equals to 1 and minus 1. When k is even in 0 to t, it's 1. When k is odd in 0 to t, it's minus 1. We can get the first order probability masses. The probability xt equals to 1. It equals to e minus lambda t, then multiply e to lambda t plus e minus lambda t over 2. The probability xt equals to minus 1. It equals to e to minus lambda t multiply e lambda t minus e minus lambda t over 2. We can get the mean, the expectation of xt equals to e to minus 2 lambda t. Autocorrelation RT1 T2 it equals to e to minus 2 lambda absolute value of T1 minus T2. The autocovariance CT1 T2 it equals to e to minus 2 lambda T1 minus T2 absolute value, and then minus e to minus 2 lambda T1 plus T2. We can get that the probability xt equals to 1. It equals to 1 minus e to minus 2 lambda t over 2. It is approaching to 1 over 2 when t is approaching to infinity. And we can also get that the expectation of xt it is approaching to 0 when t is approaching to infinity. And autocorrelation RT1 T2 is approaching to 0 when the absolute value of T1 minus T2 is approaching to infinity. It means that when T1 and T2 are far away from each other, xt1 and xt2 are less correlated. Now, next one is question 5, random telegraph signal. Random telegraph signal. We have that yt equals to a multiply xt. Here xt is a semi-random telegraph signal, and we have the probability of a equals to 1 and a equals to -1. The probability is equal, and a equals to 1/2, and we can find the first order probability that matches Pyt equals to 1 equals to Pyt equals to -1, a equals to 1/2. The main value is that expectation of yt equals to 0. The autocorrelation is that RT1, T2, a equals to e to -2 lambda, absolute value T1 minus T2, and autocorrelation, autocovariance CT1, T2, a equals to e to -2 lambda, T1 minus T2. In terms of probability mass, we guess yt is strict sense stationary, and the expectation of yt is a constant also makes us guess it is strict sense stationary. Now, next question is random walk. It means that we toss a fair coin 10 times. K is the number of heads, and then we have xnt equals to ks, then minus n minus k s equals to 2k minus n multiply s. The first order probability masses is pxt a equals to